Okay, so AB is a square matrix, then AB is P by P for some P, right? Now, then A is what? Well, AB has P rows and P columns, right? So, how many rows? But what can you say about the rows and columns of A if AB is P by P?
P by something.
Okay, well, it means that AB has P rows, so the number of rows in the product AB has to be equal to the number of rows in A, right? So A is we'll say P by N for some N. I'm not using the notation suggested in the guided proof because notation's just notation. Okay? The ideas are the ideas. Okay. Do we agree? Okay. So what can you tell me about matrix B?
It's something by P.
Okay, in order to get a P by P matrix, B has to have P columns. Okay? Now, it means you've got a matrix here with P rows and some number of columns, right? Okay? How many rows does B have to have? The rows of B must match, the columns of B must match the rows of A. They have to have the same length. So matrix B must be what? Okay, well, it's got P columns. It's got to be something by P, right?
Greater than equal to 1.
But the length of a row of A is what?
And
Oh, we draw it. It helps to have a picture to look at, right? Here's your A matrix, here's your B matrix, right? Your A matrix has to have P rows in order for the AB matrix to have P rows, because you got so many rows, right? You got P rows because this matrix has P rows. So P rows here requires you have P rows here. Okay? B has to have P columns because this matrix has P columns, right? The number of columns here has to equal the number of columns here because every entry goes in to the row of that came from an A and the column it came from in B, right? So you got P rows, you got P columns. So you get P rows and P columns. The one thing you don't know is how long the rows are of A, which has to be how long the columns are of B. Okay? If the row length in A is n, of course that would be then the row length, right? Then the column length, didn't leave myself enough room to write all this. Then the column length is n, because the rows have to match the columns. Well, if A is P by n, which means the row length is n, then B must be n by P, right? Where n can be any number. You can have any row length. But you gotta have P rows here, you gotta have P columns here. Okay? So if AB exists, then you have to have this. Okay, well, so why now is it that BA is defined? Well, because in BA, your row length is P, and the column length in A is also P. Okay? Row length of B equals number of columns in B, which is P, and the column length of A equals number of rows in A equals P. So BA exists. Okay? That's the reason. Now you could conceivably say, well, B is n by P, A is P by n. Okay? So they're compatible for multiplication, so BA exists. Furthermore, BA is what? What are the dimensions of BA?
P by P.
Are they P by P? Well, you got a row of BA for every row of B, right? How many rows does B have?
N rows.
Has n rows. So you got to have n rows. So it's not P by P, is it?
That's N by N.
Yeah. And how many columns does A have? It has n columns. So BA has n rows and n columns. Square but not P by P, unless P happens to equal N. Okay? I can maybe say, not necessarily P by P. N could equal P, but you can't assume that. Okay? No matter what N is, no matter what the other dimension of your A matrix is, the B matrix has to have that dimension, but as its second, the first dimension of A has to equal the second dimension of B for any A matrix multiplication. Okay? Now, if you have time, it would be worthwhile to make that proof more elegant. I'm trying to be explanatory and saying why it is and so forth. But how could you write a proof, a correct proof that any mathematician would say is convincing, without waving your hands, as compactly as possible? Okay, that's called an elegant proof.
We're not talking about the 1 + 1 proof that's like this thick, are we?
The what? 1 plus?
There's a mathematical proof for 1 + 1 that someone actually sat down, like a mathematician actually sat down and proved that 1 + 1 = 2, and it's thicker than our textbook.
Well, yeah, it's all set theory. Okay?
So like
So-
not one of those.
Mathematics is all reducible to set theory. But the guy we interviewed, well, I don't want to talk about this on tape. Not that I'm going to say anything bad, but I'm part of the process. So off the record, it's just mathematics. It has nothing to do with his qualifications. But